Right, guys, so I'm just doing a little Ionic, some Ionic questions now to go with the video I've just made. You do not have to watch this. If you feel confident to answer those questions yourself, then absolutely fine. Go to the questions and give them a whirl. If you don't feel very confident, then by all means, I think they've got 4 questions on this, 3 or 4 questions on this, these exam questions. Watch one and then go and have a go. If you still don't feel quite confident, obviously then you can watch the other ones. But if at any point you feel like you can give this a whirl yourself, then please do. This is always here for support, this video, and I've put the mark scheme on as well. So it says a sodium atom and a fluorine atom. So straight away, I'm looking at those two things, sodium and fluorine, and I'm going to be thinking to myself, well, sodium is a metal, fluorine is a non-metal, so we're talking about an ionic compound. So that's what I'd be thinking straight away, okay? With that ionic compound, I'd be thinking electrostatic forces, okay? And I would be thinking electron transfer. That's what would be running through my brain as soon as I saw those words, really, okay? So it says a sodium atom and a fluorine atom react together to form an ionic compound. Figure 1 shows the electron arrangements in the atoms and the ionic compound. Only the outer shell electrons are shown. So we've got here the sodium atom plus the fluorine atom. So we can see that on the sodium atom, we've got just 1 electron on this outer shell. And if we count how many we've got on this fluorine atom, we can see that we've got 7 on this fluorine atom. When they've reacted, we can see that if we just played a little bit of a spot the difference, we can see that this sodium atom has now lost its electron and it's become a 1 positive charge. And the lost electron that was from the sodium has gone over and it's on this fluorine atom, and this has gained a -1 charge. Okay. The first box says what type of force acts between the ions in an ionic compound. Well, again, because of what I said at the beginning, these electrostatic forces, this is what you should be thinking when you're thinking of ionic compounds, is electrostatic forces, electron transfers. It says then, describe what happens when a sodium atom reacts with a fluorine atom to form an ionic compound. Use figure 1. Now, it wouldn't say use figure 1 unless it wants you to use figure 1. We've got 4 marks, so I'm going to just put 4 bullet points down. And if I use them, I do it great. And if I don't, there is a prompt. I'm going to have a look at what figure 1 shows me. Figure 1 shows me, if I look at this top one, I can see that this sodium atom here at the top has lost 1 electron. So I'm going to write that down. Sodium loses 1 electron to become, and if we have a little look over here where we've looked before, we can see that it becomes a positive ion. So I'm going to write sodium loses 1 electron to become a positive +1 ion. Okay, what's happened to the fluorine? Well, the fluorine starts off with 7 electrons. It ends up, with 7 electrons. It ends up with 8 in its outer shell. I think I've just drawn over that ever so slightly. There you can see there we've got that 8th electron there. So I'm going to write that down. I'm going to write fluorine gains 1 electron to become a negative ion, a -1 ion. Okay, so I've got 2 out of 4 marks there. It says, describe what happens when a sodium atom reacts with a fluorine atom to form an ionic bond. So another thing I could say is that the sodium atom loses its electron and it's transferred to the fluorine. Okay, so I'm going to write that. I'm going to write electron is transferred from the sodium to the fluorine. And then I'm going to say that we've got these opposite, rub that out in a second so you can see, we've got these opposite charged ions. So this is a positive ion here at the top. This is a negative ion here at the top. These two are attracted to each other. So I'm going to say oppositely charged ions are attracted to each other by electrostatic forces. Okay, I'm going to leave a little pause there in the video so that you can stop it. Or you can go and try the question yourself and the next one if you want to. If you don't